Okay, so the reason I really started recording videos today is because I wanted to look at this. I saw this video from Benny, which is beautiful, as always. And I saw this instrument, the Tasty Chips GR-1, which I feel like I've seen before. And this is an interesting looking thing. It seems to be some sort of granular thing. Yeah, granular synthesizer. And I wanted to get this MIDI stuff hooked up so that I could take a stab at making something that is a bit like this in ChucK. I don't know that, I'm not going to look up how this thing works or what all the buttons do or any of that. I'm basically going to just try to build some sort of grain, cloudy, synthesizer-y kind of thing that maps to MIDI input and see where we end up with that. So I'll play this for like 1 second so we can hear what it sounds like. God, so pretty. But so this is my idea. So I like this UI. I don't really understand what it all means. I guess this is like, this blue bar is some sort of like initial scatter, like where in the sample will our grain initially start. They have some length, which is how far they travel. Or the speed is based on the pitch. So I'd imagine they have some lifetime, which is, just how long they're going to travel along the thing. And then there's some sort of envelope on the whole system, and the grains probably have some envelope of their own too. So I'm just going to wing this. I've made things like this before, but never really anything this complex. Or I've made things that are equally complex, but not with the same sort of playability. Most of what I make just kind of like randomly jumps around giant audio files. But we're going to see where we end up. So this is going to be pretty off the cuff. So I will make a new file. I'll call it, what's that thing called? It's called, oh no. It's called Tasty Chips. tastygrains.ck. Okay, so the first thing I'm going to need, before we even screw around with any MIDI or anything, is we're going to need a sound buff. And we'll need a sample. And it's always where this becomes exciting. But I'm sure we can find something. Okay, so I have this shakuhachi sample. And I like this because although it's a single note, so we can still play chords without everything getting all weird. But it still has quite a lot of complexity over time. Like there's the nice vibrato, there's a change in tone, there's some overtones that come in. There's still a lot of kind of interesting things that can happen with this sound. So I'm going to copy that, and where am I? Let's ChucK recipes, samples, let's drop that in here. I'll make a new folder called, I don't know, grain. And I'll drop shakuhachi in there. And I'll just call it ChucK. Love it. Okay, so we want to do /samples grain shack.wave ChucK to s.read and verify that works. Nope, not that one. ChucK tasty grains. Okay, perfect. So we have our tasty grains ready to rumble. So how to make something like this? So we need, at the very least, and envelope. And then we could do something like, in a loop, we could maybe e.key on 100 ms ChucK to now, e.key off 10 ms ChucK to now. And if we set s to loop, we'll get something. Make sure we got our semicolons. So this is very regular, not really what we want. Maybe we'll do a math.random. Here. This is kind of cool. But it's still very like regular. Like we're not really stretching anything, and we can't really do too much stretching with only one buffer. I mean, we can, but I don't want to get into like super complicated stuff. But we can still do something like we could have a fun void sample tick. Actually, we don't even need that. We could just say maybe we start at 0 ChucK to float or int sample pos ChucK to s.pos, and then maybe we only increment sample pos by like 100 samples or something. And then we say if sample pos is greater than s.samples, we do that, and I don't think that works. I think it's can we plus ChucK? We'll probably do the other way around, right? Like 100 plus ChucK to sample pos. What does this do? Okay, this is kind of cool. So now we're like in this thing. And then just to start, if we want to like really grain this thing out some more, we could make this a fun void. Grain voice. Maybe we set 0.2 ChucK to s.gain, 0.3 whatever, and then we could do for in I is less than 16, spork, grain voice, well one. Spork a bunch of them out. Now we're getting kind of grainy and interesting. There's a lot of crackliness. Let's make this actually 100 to 1,000. And let's set 200 or 50 ms ChucK to e dot duration. See if we can deal with some of that crackle. Maybe we'll increment it by a bit more. Okay, this is sort of in the ballpark as far as sound design goes. Oh yeah, this is a weird crackle at the end. That's kind of cool. it's kind of in the ballpark. Maybe we actually make float sample speed, or now they're all kind of moving through the sample at different rates, but they play back at the same speed. Okay, so this is in the ballpark in terms of sound, but there's a lot. There's no way to really control this. This is usually where my grain projects end, and I just like bounce this out for 20 minutes and hang out and never release it. So we should put some effort into making this a playable thing, and that's going to involve probably some classes, I think, to start with. So I'd like to make a class called voice. Voice, maybe how many grains are in a voice, do we think? I would say maybe 32. Maybe we'll start with 16. Oh, my fucking headphones. ChucK won't talk Bluetooth to these headphones, so I keep having to accidentally unplug them because they're also kind of broken. But okay, so 16 checked in num grains. That's going to be my amount of grains. We can up it later, depending on your computer and your RAM and everything like that. But so this is the start. Then we're going to have an array of sound buffs, and this will be called grains. And it's num grains long. We also will have an array of envelopes. I like to name these singularly because I feel like I interact with them. It's with a specific one more often than I interact with the array, but do whatever you like. Okay, so we've got our buffers, we've got our envelopes. They should have, maybe we'll make this, for now, we'll make it extend ChucK graph, and then we can say gain output ChucK to outlet, or I'll just call it gain, yeah. Master ChucK to outlet, and then we will say for in I is less than num grains, I plus plus, we would like sound buff, not sound buff, right? Grain, I ChucK to env, I ChucK to master. And I also want to go ahead and load my sample here. So this goes to grain I. Okay, fun. I'm actually just going to remove all of this because it really doesn't matter anymore. Okay, so we're going to initialize all of these sound buffs. Then we need some methods on this. We need a fun void key on, fun void key off. This will turn it on, turn it off. And I want a fun void frequency. Not going to worry about frequency just yet, but we're going to keep it here for later. Then this thing also needs its own method, which I'll call tick. And tick will be the thing that's basically kicking grains out and playing things, essentially. So we're going to have an int called read speed, and I'll make it 1,000 samples for now. That's a little slow, actually. I'll make it... I want it to read, like, maybe 10% of the rate of the thing. So if we were reading at speed of 1, it would take the length of the sample to finish playing. So I would like to read through slower than that, but I guess that's because we're going to be also firing at random times. It's a little tricky to do that. But let's just say like 20,000 samples. I guess it depends how often this is called. We'll change this number as we go. I'll make it 2,000 samples. 20,000 seems crazy. Okay, so this is going to while 1. Ahaha. Okay, so let's also, in addition to this, have another envelope, master env. This is always going to be kicking out grains. And then we'll use the envelope to actually like do things with it, but it's always going to kick out grains. So we want to say while 1, we would like to loop through all of our sound buff things. Num grains. So we're going to loop through all of these, and then we will say, we basically want to fire them sometimes. This is actually going to be a little funky. We actually want to do this a little bit differently. Let's say, instead of this, let's have tick accept an argument of which grain, or stupid name, grain index. And then we will while 1, grains, grain index. So what do we want to do with the grain index? We'll deal with its frequency in a bit. We probably just want to env grain index.key on. Wait for some random amount of time. Excuse me. And then key it off again and wait for some other unspecified random amount of time. So now we have this tick, and we can say for int I is less than num grains, I plus plus, spork tick I. Let's see what this does. Probably a good time to check if anything works at all. So we have, if we just create a voice V and we chuck it to DAC, V, and then, I don't know, 10 seconds, chuck to now. I'm assuming nothing will happen. We'll probably get a syntax error. Okay, well, nothing happens. Cool. So nothing happens because we have this envelope in here, I believe. So let's say v.key on. Let's wait for 3 seconds. V.key off. And then wait for 1 second. Syntax error. Good, good, good. I always miss it on the key on, key off for some reason. Okay, still nothing. Let's say 1 chuck to grain I dot loop. Make sure that's happening. Okay, this should be key off. That's a typo. Okay, so what are we missing here? This is where the real fun starts. Tick gets forked. We have some timing in tick. Let's log something in tick and see what's happening. Okay. This isn't just a case of, yeah, so we have some stuff being logged. This seems like it's probably the correct sample. They all get chucked to master. Is this a situation if we can't spork tick until that's done? I mean, that should already be done. I think this whole thing is synchronous. Oh. We never implemented key on. Ha 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 ha. So key on should extend, should just say master dot key on. It's always the little things. Key off. Okay, cool. That kind of works. Maybe we'll make master omp a bit of a longer envelope. So dot duration. Okay, fun. This is supposedly working. This is working-ish. It's somewhat boring, but it's kind of working. So let's lower this speed. Oh yeah, we're not using read speed. That's the other thing that's happening. So we want to do these all need their own read speeds and read positions. I mean, I'm starting to think that like a single grain should also be a class that handles all of this stuff. Maybe that's a refactor we'll do at the end. Okay, so we have the tick, which accepts the grain index. So I think read speed can be constant, but position is its own thing per grain. Okay, so we need an int array called grain positions, and it's going to be num grains long. And so then we would say read speed, what is it, like grain positions I, silly backwards chuckness, plus ChucK, read speed to grain positions I, if grain positions I is greater than grain I dot samples, grain positions I, we chuck 0 to it, and then we grain positions I chuck to grain I dot pos. It's not called I, it's called grain index. Okay, that's slightly better. Okay, so now we need to deal with frequency, and this is a generally more fun problem. I mean, fun being a relative term. So we need to, so sound buffs don't accept a frequency argument. They accept a rate argument, which is scaled differently. And we could figure it out, but that isn't really what this video is about, and I always forget how to do it. So I think I have it. Oh yeah, I already have it in here. Haha, of course I do. Dexter. Do I? Did I actually do it? Ah, crap, I didn't do it. Frequency quantizer. Oh, I didn't do it. Well, I have it somewhere else. sound. Here we go. This is my handy rate for note function. If I understood logarithms and stuff, there's probably a cleaner way to calculate this, but it seems to work. I don't really care about the notion of a root note here. So really this could just be n over 12, I think. I think that would work. So frequency should set yeah, that makes sense. Yeah. Okay, so for number of grains, we should do grain I dot rate should be, this will accept a int, which will be MIDI, the MIDI note. It's slightly confusing, I'm calling it frequency and accept a note, but what you gonna do? And then we send MIDI notes. We want rate for notes of MIDI note. ChucK here. So let's see if this actually works. So if I say 60 ChucK to v dot freak, probably gonna be really high. Oh goodness gracious. So there's obviously some like basic scaling that this needs to deal with, but so hopefully this should be about a semitone up. Okay, we're good. We can work with this. Okay, so we have a way of setting a frequency. Now we're getting to a point where we can start to throw MIDI back in here and see what happens. So I'm going to go back into the MIDI input, MIDI event input, and just copy most of this wholesale. Watch the other video if you want to know how this thing works. Okay, I don't care about any of this. All I care about is if data 1, we would like to say, oh, we only have one oscillator. So let's see if we can get away with the 127 oscillators here. I suspect that we can't. My suspicion is that we won't be able to get away with it, but we'll find out. Voices.length isn't length, right? It's size. I can only do size. Voice I ChucK to DAC and voice I dot freak. Let's ChucK I. This is obviously going to lead to everything being wildly too high. So what I probably want is, let's actually, yeah, let's go back in. That's what that root was for, huh? So my old version of this function has a notion of a root note, and that will allow you to basically, you know, not assume the root note is 0 and have everything be getting higher. So let's say 60 ChucK to int root, just for tradition. It's going to be out of tune. I think this is in a D or something, or an A. It's not a C, regardless. But okay, so voice ChucK to DAC. I ChucK to freak. And then we should be getting somewhere where I can say voice MIDI message.data to key on, and if it's 128, we key it off. Okay, so my guess is that I'm going to have way too much going on here. 127 times 16 is probably going to be more than my computer can handle, but we'll find out. Okay, we've got a syntax error on line 80. Fun. That's It's always the key on and key off. I don't know why I can never do that one. Yeah, too many open files. Okay, cool. That's good to know. Good, 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 good. So let's say we have a max of 8 voices. So now we're going to have to do a few more things. We're going to have to handle frequency changing and stuff. But other than that, we'll still be okay. So we only have 8 voices. So int num voices equals struct Dexter 8 check to int num voices. This can be, oh my god, num voices, num voices. Love it. We won't set the frequencies yet. And then we'll have 0 chuck to int next voice. And so if it's data 1, we actually want to say next voice dot key on. That's not going to work. I'm not going to be able to turn them off. What is the smart way to handle this? So I can use something like next voice and I can increment it, modulo it by the amount of voices, and then we'll end up in a situation where I'm always, every time I need a new voice, I just go get one, and if once I overlap, I just start removing old ones. That's fine. It's not fancy. There's no like really nice voice allocation or anything, but it'll work. My problem is when I key off, I don't know which voice to turn off. So I guess I need a map of voices and what notes they apply to. So let's do it this way. Let's say, still need num voices, but let's make an array int voice notes. I don't know. Yeah, int notes is num voices long. And then when we can still use next voice. This is probably a terrible way to do all of this, but we're gonna go for it. So when we key on, we voice next voice dot key on, and then I notes next voice. I chuck MIDI message dot data to here. And now this is the note that corresponds to, if that makes any sense. So the notes array should contain at index next voice should be the MIDI note that was played there, that was triggered there. So then when I get it off, I can look and say, okay, which index of notes has the note that just got turned off, and then I can go turn off that voice, if that makes any sense. Or I could just store all of this in the voice, in the actual voice class, like the grain voice class. Because you can only ever have one that's got that note. Let's do it that way. Is that easier? I don't know. I don't know if that's easier. I mean, it seems uglier. It seems like this should be not attached. Let's not do it that way. It seems like this should not be attached to the voice class itself. This is a separate system. So data 2 goes to next voice. Then when I get a key off, I loop through notes. So I say int I is less than num voices. I say if notes I equals MIDI message dot data 2. We want to voice I dot key off. And here, once we've just done this situation, we just want to next voice. Let's do our plus ChucK 1, the other way around. 1 plus ChucK to next voice. And I could do like if next voice is greater than num voices. Greater or equal to, I think, num voices, then 0 ChucK to next voice. Was it next voice? Okay. Very suspicious of this. Syntax error on line 66. Yeah, 66. Okay, missing semicolon, of course. Class MIDI message has no member data. Oh yeah, it's just data 2. Okay, it's running. I press a button. Okay, whatever note I press, do I get sustained there? Okay, good. So whatever note because we don't set the frequency, it seems we forgot to do that. But everything else is okay. Maybe. So we want to say MIDI message dot data 2 ChucK to voice next voice dot freak. Okay, let's see if this works. Okay, my voice allocation seems to work. Okay, this is good. This is a thing. This is kind of working. So if I show you the keyboard too, so you can see what's happening. So press a button, and that voice kind of kicks off. And that voice will kick off. Cool, so that's good. So let's do a bit more here. Let's like kind of make it slightly more interesting, or endeavor to at the very least. So this is working. I think the actual like way the grain sound is kind of basic to me. I want to bring the gain down a little bit. So 0.5 ChucK to master dot gain. Okay, this is fun. But let's see if we can do anything slightly more interesting. So the first thing I want to do is lower the amount of time these grains play for. Because I think that them being really short is almost more interesting. So that means I'm going to lower, rather than 100 to 300 milliseconds, I'm going to make it 10 mil, I'll make it 1 mil to 30 mil. And then we're going to do a bunch of clicks at first. I get a lot of clicks. Maybe I'll make them a bit longer so that I can get the envelope to actually be short enough to be helpful. So let's say I dot duration. Let's give it a 5 millisecond duration. Kind of like that weird clickiness that you got. So that's kind of fun. So this is doing something cool. Maybe we'll also do the kind of standard grainy trick of there being some random chance it may be an octave down or an octave up. So let's say the rate we'll do if, I think I can just do maybe. This is going to be too intense though. So if math dot random to random f, so this is going to be a random float between 0 and 1. If it's greater than 0.8, then we will do divided by 2.0. So half the rate would be an octave down. Then we'll do another check. If that one's true, it'll be 4. Okay, so we get 2 checks. Oh no, this is not divided by 4. This is times 2. So there's a 20% chance to be an octave down. Essentially a 20% chance to be an octave up because of the probabilities are stacked. They're not even, but I don't really care about that. And then the default case is that it would just be the rate I pick. So we should get some more harmony in here now. Okay, that sounds kind of cool. It's a little it's getting a little rumbly, a little kind of garbly. I think because they're so short now and they're kind of spaced out weirdly. So I'm going to tune the length a bit more to my liking. That works more for the aesthetic that I tend to go for. Okay, so what else can we do here? So I've got these random timings. Maybe this is something I was thinking of at first, is that rather than actually having this envelope no, I don't want to do that. I was thinking of rather than having this envelope actually affect the volume, maybe just send it to a black hole and use its last value as a probability. And then if we're below, and then we could use that to do our enveloping. So we're not getting this kind of boring sounding volume ramp. We're getting a studded probability of grains happening. But I kind of can't be bothered to deal with that right now. So this is going to stay. And this sounds fine to me. So maybe we could put a little bit of kind of frequency offset to it. So there's a possibility that we're going to go up or down. So you basically have them all be slightly out of tune from each other. So maybe we'll do, so we're still in the loop. So I can say grain I dot rate plus equals math dot random to f. Let's do negative 0.05, 0.05. And that is the other way around. And it's a plus ChucK. So now there's some random chance that they'll be slightly out of tune. I don't know how out of tune this is going to be. We're going to have the same problem if I believe they're going to be less out of tune the higher up they are, but maybe that's fine. Count up form plus ChucK on object references. 5.9. That is that, I assume. Oh. Plus grain I. Okay, so you can't plus ChucK into a function like that, which kind of makes sense. Okay, so they're a little out of tune. Maybe we bump that up a little bit. Okay, I liked it better before. I'm actually going to bring it down even more. I just want a little bit of movement, but not very much. Okay, so could we do anything else interesting here? I mean, undoubtedly, yes, we could do many interesting things, but I can't think of any off the top of my head that I particularly want to dive into. Is there anything else on that video that it seems to be doing? I mean, we've got ADSR, which we're not doing. Slides, tilt, curve. Oh, we could do panning. I mean, panning is always good. And this also, like, solves a problem that I always have, and I wanted to document how to solve. So you'll notice that whilst we can pan these, oh, I want to do random start positions too. Okay, so let's do math.random 0. So this is just going to do random starts. They're all starting at the beginning right now. 0. Actually, I don't need to do that here. I can just do it on grain positions. After random 2, 0 to grain I dot samples ChucK to grain positions I. And my semicolon. Okay, seems to be working. Yeah, we're not hitting that like weird like clicky sound. They're not all hitting them at the same time. That might be what you want. It was kind of cool, but just as an alternative approach. I also want to see what this sounds like with a different sample. So let's see if we can find something more interesting. Or not more interesting, but just different sounding. That might be cool. Get a steel drum in there. So is there a finder flying around? Okay, oh. Get this, boom, bam, boom. Steel. Let's see what we get here if I use steel instead of ChucK. That's kind of cool. I mean, what will be really cool to me is, what's that, a B? And what Shakuhachi sample was I using? I was using this A. So if I take this A steel drum, and they should be in tune-ish. Ah, don't rename it. Okay, so I take this steel drum instead. Oh, did I not? Oh, I must have just accidentally unnamed it. Okay, so steel. No, I want the A, right? Yeah, I want the A. This is steel. Okay, so this goes to the trash. Where is that button? Move to trash. This becomes steel. Now they should be... So that's my steel drum. And that's my shakuhachi. So they're in tune. So I could do something like if maybe ChucK that, else ChucK that. So now there's just a 50-50 chance that we're going to read either the steel drum or the shakuhachi, and we get kind of this amalgamation of the two, hopefully. And that's starting to sound super crazy, and I'm very into that. Especially because the steel drum is so much higher and sort of more interesting. Is there a third option we could get? Do I have anything else that's kind of in A? No, it's all percussion. I don't really want to like repitch anything and deal with that problem, so I'm only looking for things that are in A. It's going to sound kind of cool, but probably kind of similar to the shakuhachi. It might be hard to find it. A whirly, A flat. Ooh, cello. Come on, yeah. Is there a higher one? Whatever, we'll try the cello. So I'm gonna do float, choice. I need to like do one thing at a time. So that's my cello. So choice is going to be math.random2, math.randomf, ChucK to float choice. Let's say if choice is less than 0.33, we do that. Else if choice is less than 0.66, we do that. Else we load cello. It's a bit much, I think, for my taste, but it's still cool. We're getting somewhere. I think I liked it better with just without the cello, to be honest. So I'm going to delete that cello. And this is just an else. And this is just a maybe. Nothing exists. Okay. Make sure that still works. Okay, fun. But I did want to do panning as well. I started to do panning and got distracted. So you'll notice if we do something like, make a bunch of pan to num grains and send all of our sound buffs through pan I or whatever it is, and then do math.random. I think it's is it -1 on pan or is it 1? I never remember how pan works. Unit generator, pan to -1 to 1. So I want math.random to f -1 to 1, ChucK to pan I dot pan. If I do something like this, which should randomly pan everything, I don't think it's going to work. Ooh, it like really mullers my my performance, and doesn't even pan anything. Now the reason for that is that gain master, like the master gain, this envelope, and the outlet are all mono. So if we needed to pan every single grain individually, which is what I kind of want to do, this one's easy. This just becomes another pan 2. Do you want to use a gain in stereo, or just use a pan 2? It's fine. The envelope is harder. Whoa. This is completely new. The envelope is harder, and I hadn't considered the envelope, to be honest, so now I'm in a bit of a spot of bother. But I could do something like... So we're going to go master, and then we have this master env, and we're going to actually say envelope master env ChucK to black hole. And then the real problem is we can't go out of outlet, 'cause outlet is also mono. So this chub graph thing is no longer of any good, no longer of any use. What we can do is we're going to have another tick function called from void gain tick and I'm going to say master env.last ChucK to master.gain. And I'll do this in a while one ms ChucK to now. And then up here I'll spork gain tick. I think that'll work. Okay, so now we have this envelope going to black hole. All of these things get chucked into master, which is this pan 2 here. But our problem is we now can't do this move where we chuck the voice to DAC. We have to say voice.master ChucK to DAC. I think that will work. But I'm really kind of making it up. It may not work. Okay. No bueno. Doesn't seem to work. It's not last on a master env, right? It's value. Okay, now we're like panned. And it's clear that panning is pretty significantly affecting our performance. So we could get around that by maybe just saying maybe we only have eight voices, 8 grains per voice. It's a fairly easy performance improvement. Okay, I think that's cool. I think we're at a good stopping point here. I think this is a vaguely interesting thing. And it sounds kind of cool and shows off some things you can do with ChucK, which is my goal in all ways. But yeah, I was interested in this device. I thought this device looked cool. And I don't think I've really made a very good imitation of it, but I've made something that allows me to play with what I think this thing might be after looking at it for sort of 20 seconds and looking at what the knobs seem to be. But we obviously haven't built any of this stuff. There's no LFO in it. It would be cool if there was. There's not really a real envelope. They don't have separate lifespans. There's a lot we could add to this, but I think we're at a point that's interesting enough. Cool. All right. Thanks for hanging out. Peace.